Okay. Well, we're good.
Awesome.
Now we just need to. You are first, but don't worry. I have like announcements and stuff.
Oh,
I
yeah,
would
no.
estimate you'll probably go on at like 7:15 to 7:20. Is that okay?
That's totally fine. Should I rather probably go down there?
Yeah, that's fine. You don't have to have your laptop
Yeah.
up there. I just, all my devices get taken up by the live streaming, so I print out my announcements so that I have.
Very nice.
Yeah. We're good. Good. Blue. On my phone are not working across. Yeah, okay.
Yeah. Name's right. Meeting you. Nice meeting you. Right. Looking forward to hearing more about it. How are you? Well, better now. Finally. Update. I couldn't get it to update on Git. Copy it. That's like the throat drive. Fortunately, I have to copy. I have to get it later. I don't know how to do all that. I'm a guy that says, George, well, the next hour later, it's done. Here, I thought about getting hired out of this. Scapegoat. Yeah, it's his fault. Your name? John. Johnny. Why wouldn't you?
I figure it's my first.
Right.
Oh,
What century were you?
look, it works out for me.
Join us. Watch yourself. This means you.
Something I call it. Something. Yeah, that is one nice thing.
Fortunately,
The doors. That's like. That was the curve. That was the cookie.
well, don't take that one. That one's better.
Oh, yeah. I'm just gonna move the cookies closer to this flag. No, the cookies are.
Did you do the Titanic too? Or?
No, well, I think we're okay. I think just more probably lost. But we had 40 signed up for today. I'm guessing we're going to 20. 25.
Well, this is 55, 30.
Yeah, I didn't. I guess I did the rest. But there's a picture.
Not going under. Okay, so there's 55, 55, 40, 55, 60.
Hey, Thomas.
Yeah, 35.
I was going to mention your.
You guys know yeah, I saw 55, 45, and I was like,
Yeah, I was going to mention your thing. It's a tool one integrate, but are you going to talk about it?
No, I want to share 45, 65.
Oh, yeah, of course.
55,
Yeah.
35.
I didn't even think they would look at that. I was just like, it's here. Yeah, I was curious.
Thomas.
Yeah, but talking about
I just pushed the button and somebody pressed the button.
okay, so there is a call button, and they know that we're here today. Security people, so if you got challenged, it's telling you something.
pydoxtools is.
Yeah. Got it. Okay. I'll post on here.
How much time are we allowing ourselves?
I mean, like, try to keep it under 15. Like, actually, we say 5 to 7, but I really mean there is 10. And at 15, I started being like,
Let me know at 14.
okay, I'll let you know at
Because
14.
I timed myself at 17.
Okay.
I had already told them, you know, okay, like, I was a Toastmaster, and so
Sorry,
a half an hour is not a problem.
got it.
So I will, actually, a half an hour is a problem just for the audience, not for me.
Exactly. That's the real thing, is I'm trying to keep things interesting to the audience. So that's my big thing. You know, like, sometimes people babble for a long time. I'm gonna take another round of looking people, and then I guess we'll just get started and see what happens.
Yeah, it's
It sounds like everyone is freaking magic. Every day is a new album. I don't know the world.
Yes. Fair game. I mean, I'm not gonna tell them. I think a lot of people just grab one of those things. Yeah, that's very possible.
Yeah, I've been thinking about that because
It's still like Python imports. It only does what it needs. It only grabs the stuff it needs.
So when you open every time I've seen it,
You can create full
applications in Python? Not just like it's yes. Or actually, you know, this is happening. But I kind of all like I'll do that. Okay, thanks. I thought we didn't have that. At least it's just right. Okay. Well, there is, it is. But should they take your info or whatever? Pretty text. Okay. We'll get started shortly. You're in the right place. There's cookies in this one. First time at a new venue, that's always better. Might be a bit overwhelming. We'll try.
Oh, is it? Here, something like that. That's what.
I'm last, so I have a little bit of.
I had a space.
I guess. That's sort of my work here.
I made a dream.
Unless you're a math guy.
I'm having trouble breaking it.
You're a math guy or a programmer.
Sorry, the Qualcomm Wi-Fi.
Yeah.
Test. So for the Wi-Fi, it is QGuest, and then you'll get an email to the email you put in, and it'll have like a 6-character password.
Problems that you'll get an email.
So what?
Very small fonts like.
It is very small font in the email. Very small. The password, not the biggest thing.
We have to look. Got it.
Yeah. So you'll get an email.
I get an email. I was just typing in.
It's all the spam.
I got an email, so hopefully it works. Anyway.
It's all right.
Now, when we plug our, we have a.
We have HDMI, and then we have all the things. So USB-C,
Okay,
display port.
all right.
This is a different HDMI to USB-C. This one, I brought this one just in case they didn't have them, but they have this thing. So it should have all the things. Yep.
Okay.
Yep. They work eventually. I think I'm going to let people trickle in for like 3 more minutes, and then we'll just get started with announcements, and then they'll trickle in during the announcements. So anyway, yeah, we're good. But yeah, the Wi-Fi's there, and the bathroom is by the entrance. Coming from this side, it's the left, but if you just had walked in the double doors into the building, it would be on the right. So if you walk that way, it's on the left. Yeah. Okay. Yeah, we'll get started in 3 minutes. I'm monitoring. Well, when I do announcements, I will not be monitoring. But I am currently monitoring. I'm monitoring that. I'm not monitoring Twitter or X or whatever they call it now. And then, yeah, I think we're good. Anybody like post a comment on? Not that Meetup is like super reliable for this. like Meetup, not very kind of weird.
There's like ice. They didn't hide them. They did not hide them. Oh. We get on. Just roll it.
Yeah.
I'll pass it.
It eventually worked for me. Wi-Fi worked for me.
Oh, did you get it again?
Oh, Wi-Fi hotspot. That's why.
I just took it on the left. And that's why it's. Yeah. Oh. Yeah, for employees. It's not most of the people here. Anyway.
I think we're just going to get started. So we'll just do it. If it's possible to dim it slightly, but I wouldn't say it's that big of a deal. But thank you. Yes. Yes. If it's possible to dim it a little bit, dim it a little bit. All right. Thank you. You're in the right place for San Diego Python. Hopefully that's what you're here for. Hopefully it wasn't too much trouble finding here. First time at a new venue. We're working on it. But hopefully we get everything dialed in by next month. Awesome. I do want to thank Qualcomm for having us, and Drew, who's outside making sure that people can get into the door, and Urivan and everybody for making sure that we had an event space, which is important. Is there anything we need to mess with this? Okay. Yeah, you can mess with the audio and stuff. Anyway, and then if you hook the video in, it should just work. I also want to thank my co-organizer Jeremy, who helped set up all the speakers for today. So that's all good. I have a couple small announcements before we get started. I'm David, by the way. I'm one of the organizers for the Python Meetup. There are other organizers, but I'm the one who usually does the monthly meetup, at least the talking part. And we have a Saturday meetup that meets Saturdays, as you might expect. It's at 10 a.m. on Saturdays. That one's virtual, so it meets on Discord. If you're not on the Discord, you can get on the Discord. If you go to sandiegopython.org, it has links to all of our stuff, how to get on the Discord, one of the important things, our YouTube channel, which this meetup is being streamed to, and stuff like that. It has our code of conduct on there. It has a link to become a speaker, a very important thing that I will hit on multiple times tonight. Awesome. I did just a couple announcements. We have, I like to talk about upcoming conferences in the Python ecosystem, just in case you're not aware of them. North Bay Python, which is in Petaluma, California. That's kind of far from here. That's actually this weekend, if anybody's going there. July 29th to 30th. It's in Petaluma. A lot of people from San Diego go to that one, or at least did before the pandemic. So that one's coming up. We have PyCon LATAM, PyCon Latin America. That's in Monterrey, Mexico. And that's on August 24th to 26th. So I know Mexico is like a different country, but it's actually not that far. Like you could fly there pretty quickly. So, it's pretty cool to go to an international PyCon. Gotham is going to be in New York City and online in October 6th to 7th. And JGoCon US, it's here, not in San Diego this year like it was last year. That's in, it's in Durham, North Carolina this year. It'll be October 16th to 20th. So check any of those out if you're interested in any of those. We got the mood lighting going. Hopefully the video is still working. If you do want to become a speaker, there's a link on sandiegopython.org. Literally, we are always looking for speakers at all skill levels. It's just a 7-minute talk. You'll make it. If you want to talk about the issues you ran into when you were first setting up your Python environment, we would love a talk like that. If you're talking about advanced NumPy, I would love a talk on that. Anywhere in between. The people who come to the meetup, they come from all skill levels, and so we're always looking for talks at all skill levels. We like to have a mix of skill levels in the talks, so please, please, please become a speaker. I have a giveaway. Got my giveaway. I brought it. Okay, I have a giveaway, and I drew names in order, and hopefully one of these people is here. So we have a giveaway. It's a PyPortal, which is like a Python programmable display. It's courtesy of JFrog. JFrog is a DevOps platform for continuous releases. Basically, if you need a PyPI inside your company firewall, that is what their product does, among other things. So yeah, check out JFrog. And they have this PyPortal to give away today. Yeah, and if you win it, I'm going to pressure you just a little bit. A little bit of fun pressure to give a lightning talk on programming it. Cool. So hopefully one of the people whose names I drew is here today, because you got to be here to win. Eric Kottner, are you here today? You're here. You are the winner. Figure it out, and then program it, and then talk about it. The talking about it is the important part, Eric. 12-slide presentation. That's the end of my fun pressure, but fun pressure. You should feel it a little bit. Awesome. That pretty much that's me. I'm done with this stuff. I guess as our first speaker we have Thomas Meschede. Hopefully I didn't butcher that too badly. He's going to talk to us about information extraction using pydoxtools framework. So you're up first, and hopefully everything just works.
Thank you. See?
Coming up here, so it's probably just delay.
Nice. Hold on, let me do this. Never used Google Slides for this. As there's some, there, presentation mode. So, there we go. How do I go back? Okay. Okay, so this is a framework that I've written myself, and I'm working on this already since several years. COVID made it very easy for me to stay in my cave and not show to anybody, and but I've kind of crawled out of it now and published it 2 months ago or something like that, and thought I just wanted to show it around a little bit. So it's open source, permissive license, you can do whatever you want with it, and if you like it, of course. Yeah. So just to give a little bit of a background, why this exists. So I used to work in like satellite research, so this is what we did, and my colleagues. So when I got out of the research project, my colleagues finished the whole thing, and they actually sent a piece of it to the ISS. But so my part is I do design automation tasks. So I try to figure out how, with computers and AI, how to design stuff. And for that, I always had a really big problem, and that was getting the right data to do this, because for this kind of stuff, you build knowledge bases and knowledge graphs so that the computer can figure out how to put stuff together. And getting that data was really difficult. So we mostly sat manually there and built the databases and knowledge graphs and everything. So at some point, I started to use AI for this task. And so this is why this exists. So you can build like structured documents. You can out of any document, basically. And so mostly because of this background, I focus on technical documentation. So PDFs, Word documents, all of this kind of stuff, which has the nice side effect that technical documentation is so broad that you can pretty much use it for everything else as well. So it's not really, that's also why it's called pydoxtools. It's not technical docs tools or whatever. So because you can really use it for anything. And just to give you an example about, I mean, this is just some documents, like technical, like there's such a big variety. And so somehow we needed to make sense of this mess and try to do this as generalized as possible. And so this is why this exists. And I just want to give you a little demo how this works, basically. Now, of course, I have a little Jupyter notebook to show this. To just give a couple of, just an introduction of a few things that you can do with it, okay? So while, oh, here's another image. So while can I make this bigger? So this is just a small introduction. So the general concept is very easy. You just load a document like this. I hope you can all see this. Is it big enough?
Make it a little larger?
Like that?
Better.
So the general concept is that it's as easy to use as possible. So you just load a document and you can put almost anything in there already. Word documents, PDFs, images, HTML web pages, and all kinds of things. And so it tries to make sense of most of it. And then you can extract things like tables, and you can extract them simply as small functions like this. And so this is just the easy stuff. And then if you want to get more complicated, you have things like this available. And this is mostly what I wanted to do today, to show today. Where's the mouse pointer? There. So you can, for example, extract in a document. It recognizes images, tables, and text, and you get all of that out as lists. And the good thing is that it doesn't use deep neural networks for that, so it's very low resource, and it works on a CPU. You don't need to have a large graphics card to do this locally on your computer. Then you also get them as pandas data frames, the tables automatically extracted, all of this, and in an index, you can generate graphs in all kinds of ways. So this, for example, is a noun graph, so it kind of shows the relationships of the nouns between each other. Yeah, it's a little small. You won't really see a lot here. I can show later, but so basically, yeah, it's nice to generate graphs. You can extract keywords, the most important sentences, the languages. You can summarize the whole thing. You can it generates documentation. So one big thing is that in the background it works with pipelines. How much time do we have left? Okay. So in the background, I'm going to show a little slide later. You can, on top of this document class, there's a large pipeline framework in the background. You can build your own extraction functionality on top of that, and it will automatically do type inference, and write documentation with respect to the types that you gave it. And yeah, this is what it looks like. For example, for the document pipeline, then you automatically get this kind of documentation out of it. Then one thing for LLMs today, so you can compose AIs in all kinds of ways in those pipelines. So it's this pydoxtools is mostly, in some ways, you can see it as an AI composition tool. And for example, one of the things that you can do if you want to give LLMs context, what they have problems with is making sense of a context of a table, for example, or of a text, and then there is a table in there, and how to put them together, because one is usually an image. And so with pydoxtools, for example, you can tell it to leave out all the tables, like this. And so this is, for example, this document, what I have there. So this document, right, looks like this. And so what you can do now, you can tell it to leave out all the tables and give an index to where an AI could look up what the table looks like. And this way, it can actually make sense of what the table is related to, which text parts of the text. And so, for example, if we go for product extraction to what we had earlier, if I want to build a satellite and I'm extracting satellite components, then we can use this template and extract products like this. It will then recognize, okay, we have a product called Backenduro. It's in German now, so it's a little different, but with different product variants, and it will also tell you which table belongs to it. And in the table, you have the specifications, so now you can look up the specifications. And so it will take the table, and then it will first figure out what do the columns mean, and normalize the table. Automatically, for example, like here the columns are the names of the specifications, and so it also, for that process, it doesn't use large AI, but just small ones. For example, you can recognize that the patterns here, for example, whenever there's like a similar number, you know that that's probably, that column belongs to the same specification and things like that. And then you can normalize the table, convert the units to metric system, and all kinds of things, and at the end, then get a large list of specifications, which you can relate to the earlier extracted components. So this is the kind of stuff that you can do with it. Okay. So time? Okay. Then we go back to the slide. So that was just a little demonstration, just to give you an idea, a rough idea, what's possible with it and what you can do with it. Now, I still need to practice this with Google Slides. Which one is the Google? There. So yeah, some of the features, you can open all kinds of documents with it. We have, it's very low resource. You can compose LLMs. We've seen all of that. One of the notable things, for example, is definitely the table extraction, I think. So because there's no third-party dependency in there, so the table extraction is done completely in code here, and it's very fast. It's only on CPU. Basically, the code looks for patterns with fast Fourier transform, because tables are very regular, so it's a spike in fast Fourier transforms, and you can use that to extract tables. And what's also important, it works on a cluster. So because because I use this in our team for large, for scraping large amounts of data from the internet, we couldn't really use, like, for example, something like OpenAI, LLM, you can forget that in doing this kind of stuff. So everything in the framework is written in a way that you can theoretically use it on a cluster. You don't have to, though. It's just if you want to do bigger stuff. And it's fully unit tested, because the pipelines, and that's the biggest feature of this framework, I think, because the pipeline, so this is, for example, an image extraction pipeline. So if you throw in an image and want to extract a keyword, it goes through all of the stuff. And the pipelines, like the way the calculations are done, it's lazily evaluated. and so it only calculates the necessary stuff, and they're all cached. So if you do one calculation, let's say down here, and another one up here, then it will, the first time it calculates the whole way, but the second time it will only go back to where the least common, the first common ancestor appears. Okay, along the lines. You won't see anything, any of that, but it's you can see the pipelines on the web page if you want to explore them more. And you can. The important thing is, so the framework is sort of a pipeline composition tool. So you can write. So this pipeline, for example, isn't written as a whole, but there's an image extraction pipeline, and there is a keyword extraction pipeline, and other pipelines, and they're composed together and overwrite each other partially. And this way, for example, we can exchange this part of the pipeline for HTML web pages, and then hook in the entire rest of the pipeline on top of that, and have the same features for and we don't need to write the entire pipeline new for HTML web pages. And so if you want to do your own stuff, you can basically just write a small part of your pipeline and hook it in wherever you want, wherever you like, and yeah, and you automatically have all these features available. Lazy evaluation, and everything in there, and yeah, you get the idea, I think. The pipeline is configurable, so you can give each function, so when each node is, for example, an AI or function, and you can configure this function in some sort of way, how you want to extract stuff, then all of those configurations are available as hyperparameters, and you can optimize the entire pipeline. Yeah, I already went through some. So the philosophy is we stay low resource. And I think that's probably the stuff that sets the pipeline apart from a lot of other tools that do similar stuff out there now. They're probably more, I would say, app-oriented and don't really care about resources. Mine is a bit older, the tool here. So pydoxtools is pretty good on that side, I would say. Especially running these things on a cluster is a quite hard task. For example, you need the entire pipeline to be serializable so that you can send it between the different computers, and this does that. Yeah. Use case, we can talk later about that. Yeah. Right now, I'm trying to. So for example, there's this one tool out there called LangChain. Probably most people have, or a lot of people here have heard of that. And they're trying to incorporate a lot of dependencies from all sides so that the large language models can talk to other APIs and things like that. And so it kind of does the same, has the same purpose than pydoxtools. But the philosophy is different, I would say. So for example, in pydoxtools, I'm now trying to get rid of as many dependencies as possible, so that it's possible, for example, to compile it on WebAssembly, which would make it available in the browser and on serverless. And so, yeah, so that would be a nice thing, kind of where it's going now. And yeah, and the main goal is still knowledge graph extraction. And that was it, pretty much. Oh, yeah. Guys have any questions? Yes. So you can use Hugging. So Hugging Face is in there for a lot of things that if you want to, but it works without it. So it would work without Hugging Face, but Hugging Face is I have a little bit of a library in pydoxtools for all the nodes in the pipeline. And so, for example, when you load a document, the document class is simply a pipeline, and one of the nodes is a Hugging Face node where you can just like just pull in models from Hugging Face.
You're not using the Hugging Face APIs, are you?
Oh, no. No, just downloading the models. Yeah, there's no, so IP-wise, you have no problem at all with this. This also, I didn't, because there are a lot of libraries these days when you when you import AI libraries, and I did some license checks on the entire framework, so that I was really to make sure I really could put an MIT license on it. The library, not that big now, I would say. But what do you mean by big? Open for interpretation. No, not gigabytes. Like the biggest thing is when you start pulling in the AI models. That's where it gets big. But you don't need that. So for example, the table extraction is just it's just a few hundred lines of code. And I think that's also what makes it nice. For example, if you have, usually when you do table extraction and layout, so the picture at the beginning that I showed with the tables and the images and everything, it's called document layout analysis. And usually what you use for that is deep neural networks now. So you have to have at least like a 10 gigabyte or a 6 gigabyte upwards GPU on your system. And they usually use Detectron for this. And so I think this is cool in pydoxtools that you don't need any of that. And the quality is pretty good. So yeah. I'm here if oh yeah. Back again, it depends on what you mean with backend. So yes, yeah. So the table extraction, for example, to speed it up, mostly makes use of NumPy. So all the vector calculations, everything is on NumPy. I mean, essentially that's what NumPy is, but yeah. Okay. Yeah, and I'm here for anybody who has questions, whatever. And don't hesitate to send me emails if you if you want to do anything with it.
He has 24-hour turnaround on bug fix.
Sort of like that, yes.
He actually did that for me.
I have children, and they have fun sleeping times. So.
Thank you. Thanks, Thomas. All right, Gordon, you're up next. Thank you, Thomas. Gordon, you're up next. Gordon Pettus is going to talk to us about monster Sudoku with Python. What is possible? And hopefully, when you plug this in, everything just works. Watch out for this cord, which is precarious. I apologize for that. Yeah.
Okay, let's see what we got.
So, well, probably
I've got
this thing. You have
HDMI,
HDMI?
right? Yep.
Yeah. So that should just go. Hopefully.
Okay.
Hopefully the magic just happens. I heard magic happening.
Yes. Okay.
Came up here. Yeah, you're good.
Okay, my name's Gordon Pettus. My job is to create hate and discontent. And stir the pot. When I was turned 65, I read an article that said, in order to keep your mind sharp, do some of these things. And some of the examples were to do Sudoku puzzles and things like that. Well, I recently came up with a project, and I wanted to do it in Python, and I wanted to do it in tkinter, but the tutorials on tkinter were not very good. And by the way, this is a website that I developed, and most of this is in HTML and JavaScript and stuff like that. It helps people do chemistry problems. And I wanted to convert this to Python, so it's just a Python application. But I also wanted to do some other things, and I found that the tkinter documentation was not as good as I wanted. So back to Sudoku. I started doing Sudoku, and as I assume most of you know how that works. You got 9 rows, 9 columns, 9 squares, and you have to have numbers 1 through 9 in each row, column, and so on and so forth. Well, I did that for about a week, and then I said, this is really boring and annoying because you have to write down every number that's remaining in the rest of the cells. And so I said, instead of keeping my mind sharp by solving these puzzles, I'm going to switch and I'm going to make a computer program that will solve the puzzles. I did that for about a week, and then I found out that Sundays, the San Diego Union Tribune has what they call Monster Sudoku. So Monster Sudoku is like regular Sudoku, except there are 16 rows, 16 columns, and 16 4x4 squares. And so they have some of the numbers there, and then there's a whole bunch of spaces. And I said, I don't want to do that. I want to have all the numbers there. I want to use push buttons, and that's it. So I switched my program over to, let's see if I get to the right one here. I switched my program over to Python, and I started doing Python and tkinter, and this is what I've come up with so far. So you can see that there are 16 rows and 16 columns and 16 4x4 squares, and the 4x4 squares I used tkinter's frames to do that, and I put a little border on each one so that you could easily transition from one frame to another, because if you're counting to row 11, rather than count down 11 rows, you can go 4 and 4 and 3, and you can find the row real quickly. So there are 256 buttons on this in the puzzle itself. Up to the right, you have a keypad that has it's 4x4, and it has the numbers 0 through 9 and A through F. So it's sort of like hexadecimal. Some use 1 through 9 and A through G, but I was using 0 through 9 and A through F. Then below that, you've got another bunch of functions, which I'll talk about some of those a little later on. And then below that, I've got a couple of text boxes where I send messages to myself or the users or whatever. Now, here's an example of what works and doesn't work. You can see that using tkinter and something they call sticky, you can make some of these things attach very closely to each other. But down here, this text box is a little bit too long, and therefore the frames that are to the left and below it don't close up to the frames above it. This is just one of the little glitches that I have in tkinter that I haven't figured out how to do yet. And I want to be able to figure out these things so that I can, when I'm doing my chemistry program or one of the other programs I'm working on, I want to be able to have a good user interface. And the examples that I've seen simply are not that good with when you have a very large number of widgets. Excuse me, a very large number of widgets on a screen. So anyway, we've got all this mess here, and we got all those numbers. How does it work? Well, if I want to put, let's say I want to put the letter B or the number B up in the second cell up there, then what I'll do is I'll click on the B, and I'll click on the cell, and it puts a B up there. Well, that's a very simple explanation of what happens, but it's actually a lot more complex than that. Down here, I'm going to click and show the data structure, because every cell has a dictionary associated with it. And that dictionary for each button has the array reference, it has the button identification, it has the row number, the column number, the square number, whether it's done or not done, that's a true or false. It has the numbers that are in that cell, the width, the height of the cell, the font, and the color of the font. So in this case here, the foreground color is black. This is for the first cell up here, cell 0. But cell 1 is obviously now that's got B, and its foreground is red. But there's a lot more that happens with this, because each number can only appear in each row once. Same thing with the cell, the same thing with the column, and so on. So you'll see that the B occurs in this cell as a solution, but the B has been removed from every other cell in that row. And the B has been removed from every other cell in that column and every other cell in that square. So what the program does is when I click on that cell, it executes several functions. The first one changes the properties in this dictionary. The second one removes, since it's the cell is done, it removes it from a list of cells that are done, and then it updates the puzzle. And by updating the puzzle, I mean it updates all those other cells by removing the number when that's appropriate. Now, when we look down here, it says, since I've completed one cell, it says cells done 1, cells to do 255. Now, I don't want to go through and bore you by putting a bunch of these things in one at a time, so I'm just going to load a solution. And you can see that there are a lot of red numbers there now, finally, because this is what you would actually be given on a puzzle. You wouldn't have all the other little numbers filled in. You would have to fill those in yourself while you're solving the problem. But the ones in red are the ones that are actually, those are what's given to you at the start of the puzzle. Now, how do you solve a puzzle? There are several patterns. And the first one is to say, does a number occur only one time in a row? Now, if we look at row 1, I don't know whether you can see this or not, but row 1 has a D in it, and that's the only D in that row. If you look at the D at the first square, you'll see that the D only occurs once in that square. So that D has to go in that cell. If we had looked at the column, the D occurs several times in that column. So just checking the column wouldn't help. Checking the row or checking the square does help. So if you're looking for only one occurrence of a letter, you have to check every row and every cell and every row and every column and every square to see if that occurs only one time. I talked about the dictionaries that each button, each cell has its own dictionary. Well, in addition to that, I have the 256 arrays, and I made the copy of those arrays, but also there is a variable that for every row and every column and every square that keeps track of all of the numbers that are in that set, in that row or column. So all I have to do is look at that row and say, does something occur only once? What's the count of that character in that row? That makes it more efficient. So I've got several structures that are a part of the program. Now I could click on this, I could click on a D and I could put the D up there, but I've created another little program here called find single that will go through the program and look for cases where there's only one number in a row or a column or a square. And so I do that, I click on that, and there's my list of characters that only occur once in a row, a column, or square. Now I could manually update all of those, but I'm not going to do that. So I'll just click on this solve RCS and it will automatically solve those. Now, since I've solved those, that's going to open up some other possibilities. So there may be some more things that have come up where now we have more things where there's only one character in a row. So I'll click this find single again. Sure enough, there it is. Solve those, and that'll take care of some more of those pesky little problems. Now, if I click it again, there are no more cases where there is a single character in a row, a single character that only occurs once in a row. So I have to go on to the next pattern. And the next pattern says find duple. Well, what's a duple? If we look down in these, by the way, can you guys see this? There's an 8, 9 in here. So there's an 8, 9 here, and there's an 8, 9 here. That means one of those has to be an 8, the other has to be a 9. There can be, so I can eliminate all the other 8s and 9s in this square, because both of these are in a square. And since these are both in a column, I can eliminate all the other 8s and 9s that are in this column. So I'm going to press the duple, and I've just gotten rid of the 8s and 9s and the rest of the cells in that column, and similarly in that square. So that's a duple. Now, what's a triple? I don't have that programmed right now, but if we look over here in column 16, we can see a triple. There's a 5C, a 9C, and a 5-9C. So one has to be a 5, one has to be a 9, one has to be a C. So I can eliminate the other 5s, the other 9s, and the other Cs from that column. Well, down here I've got a 5, 6C, so if I eliminate 5 and C, I can just put a 6 in there, and that solves that. And I've just got another cell done. And I've got a C here, so I can do a remove. So here's a delete a number from a cell, and I'm going to click that, and then I'm going to click C, and I'm going to click on that 12C. So sometimes clicking on a button will solve a cell, and sometimes it will just remove a number from a cell. So I've got that. Now I've got 2 9s up here, so I'm just going to do a couple of these things here so you don't get bored and throw stuff at me. So I'll do a couple of those things there. And now let's get rid of these things, and let's try the find singles again. Oh, there's one. And there's some more. So by solving some of these, I have opened up some other possibilities, and now I can solve some more of them. And I'll keep doing that until until I don't get any more cells solved. Now let's look up here. I've got a 3, 7, and a 3, 7. So I've got another duple. Right now the program will only solve the first duple it comes to. So if I click duple, it's going to find that 3, 7. It's going to remove the 3s from here, and it's going to remove the 7s from here. And sure enough, it works. I could keep doing more and more of this because there are, for example, here's a quad, a 3-9 AD, a 3-9A, a 3-9A, and an AD. So that's a quad, and I can use that quad to remove other numbers from that cell. Eventually, I will have nothing left other than some duples and some triples and some quads, and I have to figure out what the hell am I going to do next. I may be able to find another pattern, and I know of one pattern right now, but it's very simple. But anyway, I have to find other patterns, and with some puzzles, I get to the point where they require that you do trial and error. So at that point, I need a button here that says save the current results. So you save the current results, then you say, all right, I've got an 8B here. I'm going to try the 8. I try the 8. I propagate that through the system, and it says, nope, doesn't work because I got 2 numbers over here that are the same. So that was the wrong thing. So now I reload the solution that I had saved earlier, and I go back to the other example, to the choice that I made before. I make the other choice, and I go through it again. So I need to save the current solution so that I can do trial and error and recover from it. Because there is no backup button or anything like that here. It's a regenerate, but no backup button. I've spent a lot of time and effort trying to get learn Python and learn tkinter to make this work for my other program. But while I'm at it, I'm sort of having fun with the monster Sudoku. I've done this before, and I eventually got to where with the Visual Basic program, it could solve almost every one of the most difficult problems by pressing one button. And that was satisfying. So I hope to get to that point with this program using Python and tkinter and also to make sure that I get the GUI stuff worked out so I can use it on my next project. Any questions other than what my wife might ask of, who are you and what are you doing? Oh, questions? Yes.
Why did you choose TK instead of something like QT or?
I tried Qt once, and it was great for drag and drop and creating the GUI. But once I created the GUI, then and this was a couple years ago. Once I created the GUI, there was no code with it. I could not incorporate any Python code and associate that with the GUI. So setting up the GUI was fine. But I wanted something that was that, and that's good if you don't actually have to have it work. If you really just want to make sure that you set everything up so it looks pretty, and the user says, "Yeah, this looks really good," then Qt would be good for that. But when I tried it out, there was no code associated with the GUI. Other questions? Okay. Thank you.
Watch your step. All right. Thank you, Gordon. You got everything? All right. Drew, you're next. I'm gonna put you third. Is that okay? All right, I'll put you to the end. All right. Drake, you're up next. Drake Redwind is going to talk to us about capture the flag techniques using Python and tools. All right. Just watch your step when you walk over here. Yeah. Don't trip on the cable. Magic. You have HDMI, right?
I believe so.
Okay.
I hope so. Yeah, on this side.
Come up here either.
He killed it.
It wouldn't surprise me.
Oh, you're coming up, I think. I saw a mouse on the. Oh, you know what? I bet it's. Yeah. You're. Okay. Yeah. Never mind.
All right.
Magic happens.
What I really need is for there to be two. Screen resolution. Let's see. So extend. Apply. And then it doesn't really matter which way it changes. So awkward on the screen. All right. Presentation. All right. All right, so how close do I need to be to this microphone?
You don't need to do that.
Okay. Hi, everybody. I am Drake Redwind, professionally that is, and I'm currently looking for a blue side, fully remote cybersecurity job. I'm here today to talk to you about capture the flag or CTF techniques using python+tools. I don't really like fluff. You can look at the O3DE engine that I'm helping out with, and I get there like 20 minutes early and solve everything before everybody gets there.
Move a little closer.
Sure thing. All right, let's see. Actually,
Bump you
let's.
up on the live stream.
All right, sure. So in this talk, I'll cover the following topics. What is CTF? Why use Python for CTF? Let me just get rid of this box. Unless it doesn't want to go away. Okay. Oh, that's why everybody's laughing. There we go. All right. Some popular Python libraries, tools for CTF, examples of CTF challenges, and how to get started with CTF. So CTFs are a type of cybersecurity competition where participants solve puzzles and challenges to gain access to flags. And they're a great way to learn about cybersecurity and to improve your skills. They also are a lot of fun. And flags are typically a string of text that represents successful completion of challenges and can literally be anything, a string of numbers, string of letters, sentences, maybe even a character that you're trying to find in a bounty hunt. Python is a powerful program language that is well suited for CTFs. It is easy to learn and use, and there are a number of libraries and tools available that can be used to automate tasks and solve challenges. So, why use Python for CTF? There's a number of reasons why Python is good, why it's a good language for CTF. First, Python is easy to learn, and this makes it a good language for beginners who are new to CTF challenges. Python has a large community, and it's active. A large active community of developers who have created a number of libraries and tools that can be used for CTF. This makes it easy to find resources you need to solve challenges. Third, Python's a powerful language that can be used to automate tasks and solve challenges quickly and effectively. This can give a significant advantage for any Python users competing in a CTF challenge. So there's a number of popular Python libraries and tools that you can use for CTF. Some of the most popular are python+tools, a powerful library for interacting with binary files in memory. That was my phone, thank you, Mr. Genevieve. Scrappy, a powerful library for packet crafting and analysis. Hashlib, a library for cryptographic hashing. Cryptodome, a library for cryptographic algorithms, and that makes things like creating a smart home a lot safer so that people don't hack into your system. They have to decrypt it first, and then they can hack into your system. Examples of CTF challenges. So there's a wide variety of CTF challenges, but some of the most common include reverse engineering, challenges that include reversing the binary code of a system and trying to understand how it functions. And all of these can include the hash codes that you have to find. Web challenges that involve exploiting vulnerabilities in websites or web applications. Crypto challenges that involve breaking cryptography algorithms or cracking hashes. One of those is like cracking Wi-Fi and whatnot. Forensic challenges that involve analyzing data to find evidence of a crime or attack. So, how to get started with CTF? If you're interested in getting started with CTF, there are a number of resources available to help you. Some of the best resources include TryHackMe, a free online platform that offers a variety of CTF challenges. Hack the Box, a paid online platform that offers a more challenging set of challenges. CTF Time, a website that tracks CTF competitions and provides resources for CTF participants. There's another one that I like to use. It's called VulnHub, but that's way up there, so I'm not even going to discuss that one at this time. So in this talk, I've covered the basics of capture the flag, how to use Python for CTF, and I have also provided some resources to help you get started with CTF. Thank you. Oh wait, I think I missed one. Yep. I hope you found this. Sorry. Thank you. One more slide. All right, so I hope that you found this talk informative and that it has inspired you to get started with CTF. Thank you for your time. Thank you. Oh yeah, I might not be able to solve all of them. I might have to take notes and then come back and solve them. But Yeah, let's go ahead and try that.
Questions?
Patience, the ability to look things up, new skills. Like when in Vulnhub, that one has a lot of really hard, complicated things to crack. I had to follow a tutorial step by step. And so it was like, oh, first you have to break this hash, then you have to use Jack the Ripper to solve this hash, and then you have to read this story, and then read between the lines, and then maybe highlight things because some of the words are colored the same color as the background, and it was just insane. Okay, anything else? Yes.
How much of this hacking is done maybe just online as opposed to maybe going to a Starbucks and just picking up anybody's password or other information, hacking into their systems?
So for a capture the flag challenge, there's actually probably 3 ways that you could do that. The way that I said for, let's see, for these 3, you go on and you have a virtual machine or a virtual supervisor. And with that one, you would install Kali Linux on your main, or I guess it's just one of your virtual machines. So you would install Kali Linux as a virtual machine, and then you would go to one of these 3 sites and download a, what do you call that? A target or a victim machine. And then you would use the Kali Linux virtual machine to hack into this one using something along the lines of VirtualBox or some Oracle. Actually, I think Oracle is VirtualBox, but I forget what the other one's called that I keep forgetting. But you would use the Kali virtual machine to hack into the other one. But there's also something where you can go online and then hack someone directly. And that one includes a lot more trust because you're hacking into their actual system. But that one is really nice because you can make sure that you harden your system enough so that people who aren't into this kind of space can't hack into you. Okay, anything else? Yes, in the back.
You're going to rate the friendly, increasing level of difference.
I think try hack me is the easiest one. Hack the box is a little bit harder, but when I was researching them for this, I saw tier 0 starting points. So let me just bring that one up again really fast. So they have now they have very easy, very, very easy stuff like that. So it looks like they're starting at a lower point now. And then the CTF time is more for competitions. So that one's a little bit more up there, but they do also have easier competitions that people who are new to CTF can get into. All right, next. Yes, really in the back. I haven't yet because I think that's the one that needs money. And yeah, and right now yeah, no. Okay, anything else? Oh yeah, I'm definitely interested in that if it's free. Yes. Thank you. Okay, any other questions? All right, that seems about it. Thank you so much.
Thanks, Drake. Just watch your step. Oh, is this your backpack also?
Yeah.
Don't leave that. I mean, yeah, I'll make sure you get it.
Thank you.
All right.
Got back to you this month.
Hobson, you're our last speaker, or actually, you're not our last speaker. You're just last on my list because my list is out of order. You're our second to last speaker, Hobson, and Hobson Lane is going to talk to us tonight about small language models. And yeah, just don't trip on the cables. Magic just happens.
You are the magician. I get my desktop over there? Just a moment. Display. Okay. Oh my. Making everything full screen. Oh, there it is. Nicely minimized. Slideshow. God, more of the slideshow button. It. Beauty. Just go back. I can't get back to the title slide. Anyway, I'm Hobson Lang, Tangible AI. Maria founded Tangible AI in 2019 at the end of the year and invited me to help her at the beginning of the pandemic in 2020, just as we're trying to serve nonprofits with AI. They decide to have a pandemic, and all the nonprofits, of course, are not getting as many contributions anymore and they have less resources for fun things like chatbots. But anyway, we were successful in building a lot of chatbots for a lot of nonprofits. We built Maya to help Nepalese teenagers get educated about child traffickers and sort of a role-playing game, figure out whether it's a legit job offer or if someone's just trying to take them to the big city to use them as slaves. And Cindy.io is Maria's original chatbot that started this whole thing. It's for imposter syndrome for entrepreneurs like her. And Search for Common Ground's a recent bot to try to find common ground and help people deal with online bullying during trying to turn those into civil discussions, bringing people together from an organization called Search for Common Ground. Rory.ai by Rising Academies is in Africa and teaching math. And you'll see a few examples of some ways you can build that as a small language model. Here's the general architecture of large language models. If you want to take the shortcut on a large language model, you would go down the left-hand side, where you have a deep learning encoder and then a decoder at the bottom here, the deep learning generator. So that makes an encoder-decoder that turns text into text. It's the transformer you've heard of. It just transforms text into text. Takes a sequence of words in and generates a sequence of words out. It's just trying to predict what's going to maximize your objective function or minimize your loss function. In this case, it's that like button on ChatGPT on a large language model. However, if you want to bypass if you want to utilize some of these bits and pieces along the way, rather than letting some magic generate the next word with that, like the autocomplete on the middle button, hitting the middle button 1,000 times, that's essentially what you're doing when you use ChatGPT. Instead, if you can use a lot of these other algorithms, like what Thomas showed, you can use an information extractor to build a knowledge graph. That's called grounding, when you use that information and feed it into the prompt of a large language model to tell it some actual facts so that it can regurgitate those facts. Large language models are exactly what it says. They're really good models of language. They're really good at manipulating words. They're really horrible at facts and things like math, like we have to do for this chatbot and anything involving common sense reasoning or logic. There's a really good study about the emergent properties of chatbots. Of course, it's by Google and DeepMind trying to debunk the whole transformer architecture that they created, and they knew that it was never going to be good at this stuff. They pointed out. Anyway, I'll answer questions about that if you're interested in the limitations of large language models and why. Anyway, we can talk about that at the end if you have questions. So you have information extractors. You can also use grammars or regex parsers to match patterns in what people say by hard coding some rules around. Well, if they're saying what their name is, then you should probably record that name in a knowledge base, and so you can look it up later. Any kind of so you can have matchers. A spacey is now the state of the art for all of this stuff. You can now incorporate transformers inside of a spacey pipeline. It's a really intuitive interface. Highly recommended. It's a Python package, pip install spacey. Okay, so all that stuff can happen up there. And then down at the bottom is when you actually turn that into text. All of the chatbots that I just showed you, they all use a template. And so you have some sort of a template that wraps that text with boilerplate text that's the same for everybody. And then you insert facts into that template or other pieces of text from other resources based on this stuff you did up here. And the conversation manager logic then it does that branching down a decision tree. Like if you remember the old days when you would go through a phone tree and it's a menu. That's essentially what a chatbot is these days. And you just got to build a much more complicated menu, a much more complicated set of intents, they're called, that decide which branch the user is intending to go down in terms of your dialogue tree. And so we have a system called carry.ai. It was at one of the first meetings here at Python user group, but when we started talking about this, we had the Carrie name herself, and she came up with the name Duchess. I don't know if any of you remember that, but that was back when we were when we had a lot of volunteers working on it, building. We were actually using large language models before it was a thing. We were using BERT at the time to create that sort of. But we were using retrieval augmented generative models, which means we're going to search Wikipedia to grab some text and then summarizing that text or rewording that text to answer somebody's question. And that's a really hard question if you can ask, what should I call myself? To find any information on Wikipedia and then generate that name was pretty remarkable. But anyway, it was a lot of fun. And we've got a long way since then. And now we've built a framework for Convo Meld is a mind meld for your bots. What you can do is you can just feed it in a script, and it will output then the conversation tree that it thinks generated that script. So it tries to guess what was the bot on one side of this conversation. And so it always assumes that the thing that starts is the bot with that first question, which is the teacher in this case. Continue the sequence 1, 2, 3. And the student says 4, and the teacher says correct. And so it creates a graph of what it thinks the logic was that generated that bot. Then you do that again for some other student with that same bot, and again, and again, and again. And you create different graphs, linear graphs. The only loops are ones that we've created ourselves just to deal with. If they say anything other than 4 or anything other than 14, then you got to go back to the original question and ask it again. And so that's just the assumption on all states. So this is a state machine. You're building a program. So we basically have a system you can think of these as regular expressions almost. You're branching through a finite state automata, and it's actually automatically programming it based on some assumptions it's making about examples of the string that it's trying to reproduce. So it's trying to reproduce that sequence of transitions in the states with a regular expression that matches it in many different situations by the multiple different scripts you've given it. And a man, Ruslan, who's a recent Master's of Computer Science graduate in Kiev, Ukraine, he's the one who put this algorithm together. He's doing a great job. He and I have a lot of good times dealing with edge cases. Like, for instance, the teacher will, in many cases, ask the same question 3 times. If they get it wrong 3 times, and they'll move on. And they'll say, oh, that's okay, let's go on, let's try something else. And so, and that's logic that you can imagine is really hard for a system like this to detect. So whenever the teacher says the same thing, our current algorithm, the current version of the algorithm assumes that now she is back in the same state. If she ever says that 1, 2, 3 question again, then we assume we've looped back to it. So it creates a loop. And if it loops back into it and then comes out when it's still a wrong answer, we basically have to stop our parsing of that script because we don't have that built in. But we have a solution. It's just not yet implemented. And that's how it works. And so we have, not only can we generate these scripts, we can merge them together. That's the meld and convo meld. And this gives just a rough idea of how that would happen with two things that are combined together. And over time, as the students say many, what we'll do is, you see here that the wrong answer that was entered, I'll guess, those 11, 12, 13. Yeah, so this is wrong answer 104. You don't see that over here. That's gotten bundled up into this default. And this would only happen if we've processed hundreds of these scripts and a lot of wrong answers have come in together, and we've just decided, and the algorithm has some logic, some arbitrary logic on some bucket of things that are always going back to the same state, and it's going to gather all of those up and put them in the default. So it doesn't. So just to simplify the graph, all of these things require assumptions, and so they'll never match a human. And so we also have a way for a human to compose and edit these graphs. We have a serialization format in YAML, so it's both human and machine readable. And so you can put all that content, all that stuff you saw there, those graphs are encoded in these YAML files, and of course, then loaded into a database. Here's a good question for the group. Is it possible to store a graph in a relational database? Is it possible to store a graph? Yes, you're right. It is possible. Now, is a relation, well, let me think about this another way. Are there any graph databases that do not store their graph in a relational database under the hood? I don't know of any. They all have tables, and they all have relations between those tables. Typically, the two tables that are required are what's called an edge list and a node list. Those are two different tables, and they have a relationship between them. It's just a recursive relationship. And they just have they have indexes. In addition to the table indexes, they have also relation indexes. So they have a lot of graph algorithms that are layered on top of that relational database. So they're really not all that much different from relational database. And all that is just an excuse for us, and we do not use a graph database. We just use a relational database, and we manually keep track of those in a Django application. That makes it easier to deploy. Here's an example of one of the interfaces we have for editing these graphs. On the right-hand side is a D3 visualization of that linear graph that you just saw there with those questions. Can anybody guess what these numbers mean? Like 1.0, and why does it go to 2.0 and then 3.0, but then it goes to 4.1 here? Can anybody guess the logic of this, of the 4 and the 0, for instance, here, or the 0, 0 at the beginning? Anybody work with graphs? It's yeah, Markov chain. I don't know. I don't know for sure. I'm just thinking of what is there any significance to those numbers? Or were they chosen arbitrarily, or is there some logic to those numbers? No, these are not probabilities. They're integers. I'm sorry. These are so think of this as a version of, maybe split it into two numbers. So it's no longer, it's not a decimal number. It's just two numbers that we put in a semantic version essentially. It's a bad way of representing the number. We should not have put a decimal there. We should put a comma. You're exactly right. So that's a better way of saying it than I tried to explain it to my team. The second number is I said it's the breadth. It's how far across the breadth you're doing a breadth. If you're doing a breadth first search of this, you would increment that last digit first as you're going through the breadth, and every time you go to a new level, you would increment the first number. But even the programmer John Sundin, he's also a member of San Diego Python user group. He used to come to Sundays a whole lot a couple of years ago before he transitioned out of med school and went into computer science and got his bachelor's in LA. He moved from East Coast to West Coast, and he's out here helping us with this kind of stuff now. And we're hoping to eventually connect this to that. So right now, this is generated from those YAML files, and we're hoping, and this is connected to our database, but it's not working lately. This was created by Vishvesh Bhat, who has his cleverly.io, cleverly.something, cleverly.io, I think, is his math tutoring chatbot service that he's created. All of this is open source. His is not, ours is. Feel free to use it. But anyway, you will go in here and you would edit those things that you saw in the YAML file in this form, and you would see it pop up here on the graph, and then and you can mouse these things. I'll do a quick demo in a sec. Okay, let's exit. Let's see if we can go to that demo now. So this is that view I just showed you. Like I said, it's a force-directed graph, so that as it gets super complicated, you can zoom in and zoom out, obviously, but you mouse over, and it gives you what those things are. And so if you want the start up at the top, you bring it up to the top, and you can mouse over the edges as well to see what triggers those transitions. So the number 11 is the correct answer, so it moves on to the correct answer state, and so on. So we're hoping this will be a little bit more intuitive than trying to dive into a massive YAML file and find things to edit. Then let's see, you can interact with the bot at carry.ai. This is that Django app I was mentioning. It's under the name Nudger, and I can share the link to. Ooh, not very small screen friendly. Anyway, I have no idea what the question was, or okay, that's not going to work unless maybe I can. There we go. It's gosh, I haven't logged in over here. That's why. Hopefully, I'm still. There we go. All right. This is another thing. We want to make obviously want to make the chatbots public. You're going to also be able to generate your own tokens and have it be private or public. And we're going to make it apparently. Oh no, this is not the bot that I thought it was going to be. Oh, never mind. I just got through doing it on a different server and not there anymore. Okay, I'll stop trying to do a live demo. This chatbot widget was built by Rashdi Khalid. I don't know if y'all remember him. He also showed up at Saturdays a lot. He's now gotten his job in Morocco, and he's working for a software development house instead of us. Let me see, what else did I want to show? That's about it. Any questions?
Are there any stochastic processes?
Yeah, are there any, what you're asking is, are there any, do we have any randomness? And Now, our algorithm is entirely deterministic, but we are, we're going to, once we're going to post-process these, so imagine it's going through the loop, and it's saying the same thing many, many times. Right now, we're going to create a new state for each one of those iterations through it, 1, 2, 3, number them 1, 2, 3, and when it gets to the third one, that's the only time that it pops out automatically. And so we're creating a fully deterministic. Then we're coming back and we're looking at that graph and trying to simplify it. And so we will gather up those three things, the three states that said the same thing, and then gather that extra parameter on the into the context variable. We're keeping track of a context dictionary. It's an arbitrary dictionary. It can hold any variables you want, like the name of the user or whatever. And we're going to make that one of the one element of the context that is required to be a match along with the meaning of what the teacher is saying. If they're a match, then we put them together. All that, long story short, if similar things are said and are followed by similar things, we're going to assume that it was a random choice that generated that thing as opposed to one of the other things that was similar. So whenever we see a bunch of states that look similar and the graph around them is also similar, we're going to use semantic matching of the encoding or the embedding of what the teacher says in the states to find that out. And we may look at the one after and the one before or something like that to make sure that they really are the same state. And if they are, then we're going to make, like you said, a stochastic random selection within one. We're going to consolidate those states into one to simplify the graph, and then make it say one of those random things that was said in the separate states. Does that make sense? And it will use the statistics that it read in the original processing of all those scripts. So you're saying that are you talking about if the student says, student I'm talking about is the user, teacher is the bot. You're saying the student says something that they have said before, and then we look that up in some database or memory and then say the same thing in response. Is that what you're saying?
Process. Rather than storing apps, literally graph.
Right. Right. I think you're describing what we're doing, but I can't tell. We're just you can think anybody who's built a compiler or a parser, this graph that we're creating, I think, is analogous to an abstract syntax tree. Or another way to think about it, it's all of the conditionals in a program, and each branch is just a conditional. And we're just trying to write a program based on examples of what that program did in the past. And that's what this graph represents. We're compiling many conversations into a bot. Yeah. I've never done this before. I've never written a compiler. I'm just trying to build something that can imitate a machine that can imitate the behavior that it saw. I'm more of a machine learning engineer. I'm used to feeding it a bunch of stuff and having it learn. But in this case, it's not learning any statistical model. It's just learning a regular expression, essentially, a finite state automatic. For this particular, Rory, no, they didn't, this particular chatbot dialogue, they did not want to have adaptive or personalized difficulty. They want the students deciding when they're ready to move on. So they have a curriculum of questions, and the teacher asks all those questions, about 10 of them, for each one of they call it micro lessons. So the count by one is a bunch of different sequences of 3 numbers, chosen by what's called a conversation designer, somebody who decided what the teacher should say. And if the student doesn't like it, they say skip or next lesson or this is boring, and then we boot them out to the main menu where they choose another lesson. Drake, you're in the back. I'm scared of Thomas's question. It's designed for one-on-one interaction. So if you had some other system parse it into multiple dialogues, then we could combine all those dialogues into what the teacher would say in each of those situations. And it would just start with, hi, I'm the teacher or whatever, and each student might have a different conversation. And so have a very broad front because it's dealing with different people, and she's got a very deep mind. It would not be a simple graph to maintain, and so we haven't tried it with that kind of stuff. We're still baby steps. We're just trying to do this, count by 1, count by 2s, count by 3s kind of lessons, and hopefully be a virtual assistant as well. We're going to add that this chart here shows how we are going to incorporate into the conversation logic more than just these templates and intent classifiers. Right now, this is just doing an intent classification to figure out which of those branches the student's going down, which of those things that have been said previously, what the student is saying now is most like. And if it's not, it uses the default. If it's not among those things at all, then we're moving on. And we're going to add in that YAML file format. You saw we have this thing called NLP. That gives the conversation designer at every state or at the global, at any level of the hierarchy, they can decide to switch the NLP algorithm. This would be, I should call it NLU. This is what it's using. Like you look for a keyword match, or you can look for a semantic match, or we have Spacey as one of the options here, where you just use the Spacey vector, or you can use BERT, which is a BERT embedding, and you look for the similarity of the BERT embeddings to what students have said in the past. Those sorts of things, and it's going to be configured. And we're adding those. So Vlad S., another Ukrainian who's working on this project, he's basically he's the only person who's full-time on it now, because it's amazing how cheap you can get some fabulous talent in Ukraine right now. If anybody needs help doing that, I can show you how we did it. We have 5 Ukrainian developers, 3 in Ukraine at the moment, 1 in Berlin, 1 in Belarus. All of them, most of them part-time and extremely, extremely cheap. And very, very competent. Yes, Drake again. If the students stay on topic, what does the AI have to what? You want to encode into the bot a coherent conversation. You want to, and it needs to be finite in length. Yeah, you want to start with as much commonality as possible. You want to start from a common starting point. You want it to all be in a teacher's brain as she's starting a particular activity, a particular lesson, a particular, yeah, you could just assume that all the students are behaving as one thing and the teacher's talking to them all at once. It just doesn't seem like to me that would end up with a very coherent graph, because the teacher's going to be distracted in various different directions. I don't know. It just seems like to me it'd make a lot more sense to focus on what was the few things she said to one student before she shifted gears and started saying different things to another student. One more here.
So, how do you handle words?
So like that was a really tough problem. Like when they're spelling the number 11, or we got the answer dirty 2 and dirty instead of 32 in many cases from Africans. We just have a semantic matcher. We use embeddings to accomplish that. However, I discourage. They're switching over to a large language model despite our advice, which will handle that just fine. But it'll just guess, and it won't actually be. They'll find that they're going to run into trouble. But anyway, we recommended that they actually be rigid about properly spelling and formatting and proper grammar on number expressions, on numerical expressions, on any mathematical expression. Because you're teaching math, you're teaching this language. We recommended. We built a package. We have several packages on PyP right now. We have math text, which is designed to do what you're talking about, to pull out numerical expressions, things like greater than and less than, and seeing those as symbols or as words, and converting between the two and normalizing them to a mathematical expression. So we have math text that does that, and we have math active, which does the other thing that somebody mentioned and gradually increases difficulty programmatically. That's one of the techniques you can use for conversation graphs is a programmatic generator. So where you just write a Python program that decides what to do, has a bunch of if statements. It says if the student has answered this many correct, then it goes and does something else. And so that's what we use. We call it math active, where we ask questions that are appropriate to a student's number of questions they've gotten correct in the past. Neither of those. The math active is not interesting to our client, Rory, so they're not using it. Because they have a PhD from Cambridge who has his own ideas. The other, what else? We have another package. So math text, Convo Meld is also a package on PyP. Nudger and Carry. They're all packages on PyP. Yes?
What's the scale of this? So, correctly, the combinations of models, they all have to be technical and be logic.
We make assumptions that there's some that basically.
You have two conversations and they go different ways.
Yes.
Okay,
Yeah.
So that does not work, right?
Right.
So how does this handle that?
Yeah, we haven't yet encountered that in real conversation, and except in this situation where it came into the loop and they said the wrong answer and the teacher went on. So there is no logic inside the brain that we're doing this. We're not actually doing any NLU during the parsing of these conversations. We're just doing exact string matches, and we're assuming that it's a rule-based chatbot that's not doing any kind of thinking. And so we're looking for very deterministic rules that we can infer from what we're seeing in the history. That's it. Yeah, that sounds exciting. I don't know how we would do that, but let's brainstorm at the next Tuesday and let's figure it out. I'd love to try that. Thank you.
Thanks, Hobson.
All right. Thanks for coming. Well, I think we're going to save Drew's talk for next time because I'll get us out of here by 9 o'clock. So thank you for coming. If you had any issues getting into the building or anything like that, come talk to me after. I want to understand issues finding the building, getting into the building, all that stuff before next time.
Parking as well.
Parking.
Know about it.
Yeah, all the difficulties. I want to know about them so that we can try to nip as many of these in the bud as possible before next time. But otherwise, I do want to thank the speakers. I want to thank Qualcomm for having us. I want to thank JFrog for the giveaway, and thank you for coming to San Diego Python. That's it. See you next time. All right, that's it.
That's good stuff.